Hello, boys and girls. How are you doing? It's Mr. Joseph. This is a re-recording of June 12th's video because of the fact that the previous video was completely blank. You can see that. So I have to re-record the video, and that's fine. I'm okay with that. We're going to be on page 128 today, and we're going to be learning about ratios. So let's get started. In this concept about ratios, what you're going to be doing is learning about proportions, okay? Just comparing two different numbers to one another, all right? We looked at the concept of multiplication last time, so this is completely different, all right? This concept's actually kind of fun. I really enjoy it because it shows a quantitative relationship between two amounts showing the number of times one value contains or is contained within another. So it actually looks at mass and volume and just counting numbers. It's more interactive, I would say. Okay, so if we're looking at the quantity of girls versus boys in a school, we can just count them, right? 5 girls to 15 boys. We just count the numbers. And we use a little colon in the middle to show the comparison. We'll look at that in a little bit. If we wanted to find the comparison or the proportion between the number of squares and the number of diamonds, we just count the number of red squares, right? 3, 6, 9, 12, 15 red squares, and 4, 8, 12, 16, 20 green diamonds, right? So 16 to 20. We can also look at these ratios in a concept that looks pretty similar as a fraction format or other formats. For example, what is the ratio of circles to triangles? Easily enough, we can just say 8 to 7. In other words, 8 to 7. We use that colon right in the middle to show the ratio. We can also show this as a fraction. These are two different ways to show a proportion, as a ratio or as a fraction. This is a really important concept later on when you become an adult. We use ratio in lots of different industries. So let's take a look at page 128 and do the first 6 problems, okay? This concept is, again, pretty simple. All we're pretty much doing is counting. So number 1 says, the ratio of the number of tables to the number of chairs is, well, you just count, right? How many tables do we have? And how many chairs do we have? Easily enough, 3 to 4. You'll notice that we put that little colon right in the middle, all right? I already have it in there for you, and the book already has it placed there for you. So it's just 3 to 4. Now, letter B is just the opposite, right? The number of chairs to the number of tables. Well, we would do 4 to 3. 4 to 3. Good. Number 2 says, what is the ratio of the number of triangles to the number of squares? Well, let's count the number of triangles. 1, 2, 3, 4, 5. 5 triangles. And the number of squares? 1, 2, 3. 5 to 3 is your ratio. Again, remember you put that colon right in the middle of the two numbers to separate the proportion. What about letter B? Well, it's just the opposite. The ratio of the number of squares to the number of triangles is 3 to 5, or 3 to 5. Good. Pretty simple. We're just counting, right? Number 3. Number 3, we're working with some food. Who's hungry? Let's take a look at the number of chilies and the number of tomatoes. Now, this is going to get a little bit more complex, and I'll tell you why. If we count the number of chilies, we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chilies, right? And the number of tomatoes is 1, 2, 3, 4, 5, 6 tomatoes. All right? If you just put 10 to 6 inside of this blank, it's going to cause a little bit of stir in the math world, because what we need to do is we need to make this a simple ratio, okay? So we're going to actually simplify these numbers. And by doing that, we can just easily group the numbers. So the chilies, we can group them into groups of 2, right? 1, 2, 3, 4, 5 pairs or 5 groups. So we have 5. And the tomatoes, we have 1, 2, 3 pairs. So our ratio is 3 to 5. In other words, 10 to 6 is the same as 5 to 3. It's just a simplified ratio, okay? When in doubt, make sure you simplify the ratio. Okay, make sure you make that ratio very simple, okay? So, letter B is just the opposite, right? We would take the tomatoes to the chilies. Well, we already know that there are 3 to 5 groups of tomatoes, chilies, okay? Let's look at number 6. Same concept. We're going to be simplifying again. Let me change the color to, let's pick pink again. We have the ratio of the number of circles to the number of triangles. Well, if we go ahead and count the number of circles, we can come up with 6. But I wouldn't write that in your blank just yet. That's because we need to simplify. And if you count the number of triangles, you have 3, 6, 9 triangles. However, if you understand the factors, 6, 2, 9 can be simplified. We can divide each number by 3, right? So divide 6 by 3. Oops, what happened to my number? Oh, it's in white. Let's pick a different color. Let's go black. Here we go. That's much better. 6 divided by 3 and 9 divided by 3 is going to give us 2 and 3. So in other words, we have 2 groups of circles and 3 groups of triangles. 2 to 3 is our simplified ratio. And just the opposite for letter B, just like the other problems, we have 3 to 2, the number of triangles to the number of circles. All right, good. Let's go on to the next problem. Number 5 says that we're supposed to find the ratio of the length of ribbon. Now, just like I said before, this concept of ratio really equates to a lot of different types of math, okay? So this is working with length, if you remember that from 3rd grade, all right? The concept of length is something that we are constantly looking at in math concepts, okay? So if we count it, we can count 1, 2, 3 for ribbon A, and 1, 2, 3, 4, 5, 6, 7 for ribbon B, right? So 3 to 7 is your ratio. What about letter B? Pause the video and try it on your own. All right, hopefully you paused the video. The answer should just be the opposite, right? We have ribbon B first, which is 7, and then ribbon A next, which is 3. Our ratio is 7 to 3. Perfect. All right, so far so good. That's been pretty simple. Now we're going to make it a little bit more complicated. We're still going to remember that we need to simplify, but we also need to understand that sometimes it's going to ask for more information. All right, so let's look at the next problem, number 6. Number 6 says, what is the ratio of the mass, which is kind of like weight, okay, of box A, which is 2 kilograms, to the mass of box B, which is 5 kilograms? Well, it's pretty simple. We can just take our 2 and our 5 and put that into our ratio, right? 2 to 5. Now, letter B, just like the other ones, is the opposite. Letter B comes first, so that's 5, and letter A comes next, which is 2. Now, when we look at letter C, we need to really be careful with what it's asking. It says, let's read it. The ratio of the mass of box A to the total mass of the 2 boxes. Well, if I take the total of both boxes, it's just 2 plus 5, which equals 7. So again, we're going to put our ratio of box A, which is 2, to the total, which is 7. 2 to 7 is our ratio. Good. Now, number 7 is a little bit more complicated because we really need to understand how to simplify this. These are going to be working with a lot bigger numbers, and our simplification process is a little bit more complex. So let's do it together. It says number 7, page 130. The ratio of the volume of water of container A to the volume of water in container B. Well, here is container A, right here, and here is container B. These are both beakers. In chemistry, you use beakers to measure the volume of water, all right? If you'll notice, the water level goes up to this number right here. What is that? It says 500 milliliters. Okay, the water level, it looks like it's above 500, but that's actually, because of surface area, it actually shows us exactly 500 milliliters. And for letter B, we look at this number, and it shows that there are 700 milliliters inside of the beaker. Now, if we put, for example, 500 to 700 inside of our answer blank, that's not correct. Why? How come? Well, because we need to simplify just like the other problems. So how do we simplify 500 and 700? Well, if we look at our ratio 500 to 700, I know that we can divide both sides by one number to get a simplified ratio. What can we divide both numbers by? Well, we can divide both numbers by 100. If we divide 500 by 100, we're going to get 5. And if we divide 700 by the same number, 100, we're going to get 7. So our new ratio is 5 to 7. In other words, this is representative as 5, and this is 7. So our ratio is going to be 5 to 7. All right, letter B is just the same. It's just the opposite, right? Container B has a ratio of 7, and container A has a ratio of 5. So we're going to flip it, just the opposite. 7 to 5. Our ratio is 7 to 5. Letter C is similar to the other problem that we did, number 6, in that we need to find the total. So let's read this problem together. It says, the ratio of the volume of water of container B to the total volume of water. Well, I know that my ratio of container B is 7, but now to find my total, I'm going to just add, right? 5 plus 7, which equals 12. So my ratio is going to be 7 to 12. Boys and girls, hopefully you understood this concept. This is not only a review of what we did on June 12th, but also on June 16th, okay? Finding those equivalent ratios. So we need to really understand this concept. If you need a little bit more support, go ahead and take a look at these exercises that we did, and then look back on some of those games that are inside of the notes column of this video. So we will see you guys later next week, this Friday actually.